Hello, ladies and gentlemen. Welcome back. Today we're going to be talking about quadratic functions, basically kind of looking at some of the elements that makes up the function and some of the things we're going to be looking for and what those look like on the graph of a quadratic, aka a parabola that we've talked about before, okay? So let's go ahead and let's get into this, what a quadratic function is. Well, a quadratic is actually a special form of what's called a polynomial function, okay? So a polynomial is a function is an expression of more than two algebraic terms, especially the sum of several terms that contain different powers of the same variable. Basically, what we're looking for is we have a bunch of different terms being added or subtracted together, and they're made up of these kind of different parts. They have some sort of coefficient, they have a variable that's the same the whole way across, and then they have exponents with those variables. And as you can see, this kind of shows you in a general sense what that looks like. You have some sort of coefficient, a variable, and an exponent. Another coefficient, a variable, and then a lower exponent, on and on and on, until you have to the second, to the first, and then just a constant term with no variable there, okay? We've actually seen a few polynomials. Last year you dealt with one a lot, which would be a linear function. That's a form of a polynomial. That kind of just is these last two portions. Oh, didn't mean to click there. These last two portions here, that would be like a linear function, right? As something times x plus something, that'd be your linear function. In order for it to be a quadratic, that will be a polynomial with what we call degree 2, meaning that the highest exponent that it has is 2. And by the way, the exponents for these do have to be whole number exponents, so we're not dealing with like negative exponents, not dealing with integers. We're also not dealing with fractional exponents. They have to be whole number exponents in order for it to be a polynomial, okay? But anything of power 2, so basically these kind of last three terms, anything with that degree, that would be a quadratic, as we kind of seen so far what we've been talking about. There's three different ways that we can write a quadratic. These are the three different forms they come in. The first one is the standard form. That's the one that kind of looks like our last slide, where it's something times x squared plus something times x plus something. Okay? X squared plus bx plus c. We've seen a lot of quadratic functions over the last week or so that have been in that form. Okay? The other form that we've seen a lot is actually, if we skip down to this third one here, the intercept form. That's kind of also can be called a factored form, where we've already factored the quadratic, and that kind of shows us different information that we look for. And we've turned a lot of quadratics in that form over the last couple days as well. The kind of other form that we can have is a vertex form, and that's also going to kind of give us different information, as we'll see. The vertex form is really nice for telling us the vertex. I know if that's kind of shocking, who would have thought that? But the vertex form, we can actually kind of see the vertex and pull it right out of the quadratic. You also should kind of recognize the vertex form a little bit because it's very similar to our transformations. We talked about those in general for functions. This is sort of the makeup of our transformations, right? Something being added or subtracted on the inside, something being added or subtracted on the outside, something being multiplied, okay? So we can kind of see this is almost like our transformation form, and then we have where we factor it, and it tells us the intercepts, and then we have the standard form, which we've seen a lot of quadratics written that way. A graph of a quadratic is called a parabola, okay? It's a parabola, and there's three major parts to a parabola that we're going to be trying to identify. It's kind of the main goal of what we're going to be talking about today. The three major elements of the parabola, which are elements of our quadratic function, are the roots, the vertex, and the axis of symmetry. Now, one of these, or here's a picture, okay? With this quadratic, so here's a parabola here, we can identify each part. So this part right here where it touches the x-axis, we already know that to be the roots, but that also in this specific case is also going to be our vertex. The vertex is where your parabola kind of changes direction, right? So where it goes from going down to going up, that's going to be your vertex. So in this parabola, that's the vertex. It's also the root because that's where our x-intercept is. And then the axis of symmetry is basically that line that you could draw where your parabola is symmetrical. Okay, where does it fold on itself? Where is it symmetrical? Okay. One of these things we've already kind of learned is the roots. We've already talked about how to find those, so we already know how to do this, right? You set your quadratic set equal to 0. You solve for x, and that'll tell you the roots. We already know how to do that. We can use factoring. We can use the quadratic formula, and we can use completing the square. It doesn't matter to me which method you use if your goal is just to find the roots. As long as you can do one of those methods to find them, you'll be good to go. Do remember, though, when we talk about finding the roots, when we're factoring, it has to be a factorable quadratic. Not every quadratic is factorable, and if that's the case, you have to fall back on these other two methods, okay? So I just want to do a little bit of quick review. So go ahead and pause and take a minute and just tell me what the roots are of these three functions. See if you remember how to do that. And then we'll come back together and we'll talk about what these roots are. But set them equal to 0, solve, and you tell me what the roots are for these quadratics. All right, and we're back, and here you can see I went ahead and found the roots for each of these. So the first one, you say equal to 0. This one will factor. I got x equals -9, x equals -1, so there's my two roots. This one I had to use quadratic formula, or you could have done completing the square, and I got 5 plus or minus square root of 13 over 6, and so I put those in my roots. And the last one, you said equal to 0. You can divide by 4 and extract square roots. You can just square root both sides, and you're going to get that x equals 0, okay? So 0, 0 would be my only root. I only got one answer for that one, okay? So that's finding the roots of quadratics. The next thing here, we can talk about how to find the vertex. So the vertex, again, this is kind of the changing point of your parabola. So if you think about having a parabola, okay, if we have a parabola, the U shape that it is, okay, that turning point, that point right at the bottom there, that's your vertex. That's where it's kind of changing from going down to going back up again, okay? And the way that we find that, we actually can find it algebraically. So either you look at the graph and just see it, or algebraically, it kind of depends on what form you're in. The easier form is actually this bottom one, okay, the vertex form, because it tells you it right here and right here what it should be. It's going to be HK. And that kind of makes sense if we think about our transformations, right? Transformations, this would move it left and right, aka the x, and this would move it up and down, aka the y. And if you think of your parent function, it's at 0, 0, so it's going to move h units wherever that is, and then it's going to move k units wherever that is, okay? So your vertex is just going to be h and k. Do be careful, the same sort of trick is involved with this as it is with your transformations, in that h will always be the opposite of what you see. If you see x minus 3, 3 is going to be your h, okay? So you want to be really careful about that. Now, if you have one that's in standard form, you have to do a little bit more algebra, and we're going to see a little bit later about where this comes from, but for right now, we're just going to do it, okay? The vertex is going to be from -b divided by 2a. So you take whatever coefficient is with your linear term, whatever coefficient is with your x squared term, your quadratic term, okay, and that's your b and that's your a, your leading coefficient and your coefficient with the linear term, and you just do -b divided by 2a, and that's going to give you what that x value should be. In order to get the y value, you're literally going to take whatever number you got there, plug it back into your equation and see what comes out, okay? So we're not going to do any sort of like tricksy algebra to get that. You just plug it back in and see what comes out. And so we would say that that would be f of -b over 2a. Basically, take whatever you got from the x value, whatever that -b of 2a is, plug it back into your function, and that's going to be your y value, whatever comes out, okay, which makes a lot of sense. So based off whichever one you're seeing, that's going to be what you're going to use in order to find that vertex, okay? So let's look at a couple examples. Here you can see we have 3 different quadratics, and we're going to find the vertex of them. The first one I can see is in standard form, so I'm going to go ahead and do that -b over 2a. So in this case, it's going to be -8 divided by 2 times 1, which -8 divided by 2 is going to equal -4. So I know that that is going to be the x value for my vertex. For the y value, I'm going to plug -4 and just put it into my function. So I'll do f of -4, which in this case would be -4 squared plus 8 times -4 plus 14. Okay? And if we think about that, -4 squared is 16 plus 14 is 30. And then 8 times -4 is -32. So 30 and -32, f of -4 is going to be -2. And so my vertex is going to be -4, -2. That's going to be the point where that turning point is occurring on my graph, okay? The next one's in vertex form, so this one's really easy. I don't have to do any algebra for it. I just look at it and go, oh, my h value, that's going to be 4. My k value, that's going to be 9. Bada bing, bada boom. We've got our vertex, okay? So vertex form, that's why it's called vertex form. Really easy to get the vertex. You don't have to do any algebra. For this one right here, we're actually still going to be using the thing we did for standard form. But Mr. Guy doesn't look like the other one. How is this standard form? Well, secretly, there is a 0x hiding here, right? A coefficient of 0. It is hiding there. So my b value is actually 0. So when I go do negative b over 2a, I'm going to get 0. 0 is, in fact, going to be my x value. And to figure out the y value, I'll plug 0 back into this function, which actually is pretty easy because 2 times 0 squared will just be 0. So my y value is going to be 9 because 0 plus 9 is 9. There's my 3 vertexes. Okay, so standard form, negative b over 2a. Vertex form, we're just pulling it right out and we're good to go. Last but not least, we have the axis of symmetry. The axis of symmetry, the axis of symmetry is actually pretty easy because if you found your vertex, you get your axis of symmetry for free. It is a vertical line that goes through your vertex. Vertical lines, if you remember, are of the form x equals a number. In this case, to find that axis of symmetry, it's going to be x equals negative b over 2a. It's going to go through the x value of your vertex. So if you have your vertex, whatever that x value is that you found, x equals that x value will be the equation of the vertical line that goes through that point. And again, on a graph, what we're talking about, if you think of a parabola, the axis of symmetry would be the vertical line that kind of cuts your parabola in half and is the place where it would be symmetrical on itself, okay? Now, one example, so let's see I have this here. I just need to find my negative b over 2a. So in this case, that's negative 4 over 2 times 1. Which, if I do that, is going to equal negative 2. And so x equals negative 2 would be my equation. That's the axis of symmetry. Pretty simple. All right, so that's our work for today. That's what we're talking about. You need to be able to find roots. You already know how to do that. We've learned that before. You need to be able to find a vertex, negative b over 2a if you're in standard form. If you're not in standard form, you just look at it. Pull it right out, okay? And then the axis of symmetry, if you can do that negative b over 2a, that will also tell your axis of symmetry, x equals that number, all right? Those are some of the important points about a quadratic and their graphs parabolas. Thank you all for watching.